Alright, so we have a question here, which is starts off with, a driver in a blue car traveling at 50 kilometers per hour sees a red car approaching in his rear view mirror. The red car is traveling at 60 kilometers per hour and is 30 meters behind the blue car when first spotted. The first part of the question asks, how many seconds from the time the driver of the blue car first noticed it until the red car passes? So what kind of information can we get from this part of the question? So we know that the blue car is traveling at 50 kilometers per hour. And the red car is traveling at 60 kilometers per hour. And we can also see that from this part right here. The red car is actually 30 meters behind the blue car when first spotted. So I could call this distance right here 30 meters. And we want to know at what time will the red car pass the blue car, which basically means when will they be at the same location. So I'm gonna just call this D. So we could set up an equation using this formula. S. I'm guessing this is actually displacement is equal to the initial position plus v naught t plus 1/2 at squared. But we don't have acceleration. This is we're talking about constant velocity here. So we could just get rid of this. So we're left with this. And I'm gonna switch colors. Okay, we actually have two equations that we could get from this question. Okay, I drew this both in purple, if it could show up on the camera. They're both purple because I really want to emphasize that they're at the same location when they pass each other. So that's why they share the same D. Okay, that's I could call this the final displacement, I guess. Okay, so the first equation, I'm gonna say, okay, so you have two options here. Because they're 30 meters apart from each other, you could call this, you could say that the blue car is 30 meters ahead of the red car. So you could say that the blue car is actually starting at the position 30 meters plus the velocity of the blue car, 50 kilometers per hour times time. And then for the red car, we could give it this equation because basically I'm calling this 0, this position, and I'm calling this position 30. So its initial position is 0, so we don't have anything for initial position. So I could just the displacement equation for the red car is just going to be v naught t, and the velocity of the red car is 60 kilometers per hour times time. All right, so we're trying to look for time, right? So we have our equation. Since d is equal to 60 kilometers per hour times t, we could substitute this d with this this part right here. Okay, and after substitution, this is what we're gonna get. 60 kilometers per hour times t is equal to 30 meters plus 50 kilometers per hour times t. And we're going to solve for t. And if you don't know where I got this, I literally just, d is equal to 60 kilometers per hour times t. So I just threw this, I just substituted d with this. Okay, these are the same. If you see the connection right here, this is equal to this, they're the same thing, and this is equal to this. So d must be equal to this d right here. So that's where I got this from. And right here, you want to isolate t because that's the time, we're looking for time. the time when they pass when the red car passes the blue car. So you could bring all the t's to one side. So you get 60 kilometers per hour t. This is gonna minus, right? Minus 50. Okay. So it ends up on this side. 50 kilometers per hour t is equal to 30 meters. But this is, we actually have to convert these units and stuff, right? So I could say that 30 meters times what? 1,000? What is this? Oh shit, my bad. This is 30 meters. Alright, you know what? I'm gonna keep this as meters, and we're gonna change these into these kilometers into meters. And the part A asks for seconds, so we're gonna change this into meters per second. How do we do that? We do 60. Okay, we could do this off to the side actually. Okay, we'll do it off side here. Okay, 60 kilometers per hour. Okay, multiply. So we want seconds now, right? So there's 1 hour. In 1 hour, how many seconds are there? Okay, so I'm just gonna do 60 minutes in 1 hour, and then 60 seconds in 1 minute. So we got 3,600 seconds. And then we want to change this into meters instead of kilometers. Okay, so in 1 kilometer, there's 1,000 meters. So what's this equal to? 60 divided by 3,600 times 1,000 is equal to this. Okay, 16.6 forever. And we're gonna do the same for the acceleration of the blue car. Okay, so that's 50 times 1,000 divided by 3,600. Okay, get 13.88 forever. Okay, and this is in meters per second, meters per second. Okay, so I'm gonna just substitute this into this, and this into that. So what's our new equation? We got 16. We'll just round this to 16.7. Okay, 16.7 meters per second times time minus, we'll round this to what? 13.9. 13.9 meters per second times time is equal to 30 meters. So what do we have? We have a t in both of these, so we could just factor that out, right? 16.7 meters per second minus 13.9 meters per second is equal to 30 meters. So you could just, I'm gonna do this on a calculator because I'm bad at math. Minus 13.9, 2.8. Okay, so we have t times 2.8 meters per second equals 30 meters. So you divide, so you isolate t. Okay, so 30 meters over 2.8 meters per second, and you see how this these units cancel out. The s comes over to the top, right? What do we get? 30 divided by 2.8, okay, is equal to around 10.7 seconds. Okay, so we answered part A. This is the answer. And then part B is asking us, how much further down the road will the blue car travel in this time? So all we really have to do is just take this equation again. Okay, so I'm not sure if it's asking for like the total displacement or just like this part. So we could do both. Okay, if we want to do both, then we do the initial position plus the velocity, which is we said it was 13.8, 13.9 meters per second, and then times the time traveled, 10.7 seconds. Okay, so what's that equal to? Okay. Oh, we could actually answer both things right now, because if you just took this part, then that's the distance over here. If I add 30, then it's this whole distance. So if I'm talking about just the distance traveled from 30 to D, then that would be 148.73 meters. Okay. And if we're talking about the total distance, total displacement, it's 178.73. And thus we have answered part B. I don't know which one it is.